Hi everyone, just wanted to take a minute to talk a little bit about coordinate proofs, and I'm going to go over a couple different examples of things that are rather typical for you to see. The first one will be dealing with numbers, and the other one will be dealing a little bit more with letters and variables that you would encounter as coordinates. All right, so this is a very typical first one that you could see in terms of coordinate proofs, and you're proving that a triangle is right. You could prove that a triangle is isosceles, that it's equilateral, whatever. But the thing that's important here is that you're proving that it is right, which means that you are ultimately going to need to show that there is a right angle. Um, so this is one of the few instances where you're actually going to be looking for an angle. Most of the time, you're looking for distances. But ultimately, what we need to do here is we need to show that it is a right angle. All right. So your first step is always going to be just kind of do a quick sketch. It doesn't need to be anything, super specific. All right. Here's D. A would be something like that. Probably a little lower. A. And then N will be up here. Okay, so we have our triangle. And the reason that we really want to do that too is we can kind of see, number one, which ordering they're connecting in. And then number two, you kind of get an idea of what you're looking for, right? So our goal is to show this is a right triangle. We're probably not going to look and figure out if this angle or if this angle is a right angle, um, right? You're looking at it and going, well, it's probably A. So in order for us to show that A is a right angle, we would need to show that the lines are perpendicular, I'm sorry. The lines are perpendicular. If we can show that the lines are perpendicular, then this is going to be right at a right angle. And when it meets at a right angle, we know that this is a right triangle, right? Um, so let's go through that process. So to do that, we need to look at, well, we can find the equations of the lines, but we really don't need to. We just need the slopes. That's all we care about. So let's look at the slope of dA. So we have our change in y, 4 over 1, over our change in x, so negative 10 minus a negative 4. So we have 3 over negative 6, which is negative 1/2. Now, for these to be perpendicular, we need the slopes to be opposite reciprocals. So the slope of NA would need to be 2, right? So what do we have for NA? We have the change in y, so 5 minus 1 over the change in x, negative 2 minus a negative 4. So we'll get 4 over 2, which is 2. Now they are opposite reciprocals, which does mean that these lines are perpendicular. Because the lines are perpendicular, they meet at a right angle. Because there's a right angle, the triangle is right. That's what we would need to say. So once you've done this, you should say a sentence or two. So we know that we could say something like, the slopes of dA, and I'm talking specifically about the line here, right, of line dA and line NA are opposite reciprocals. So the lines are perpendicular. As such, angle A is right, meaning triangle DAN is right. Okay, so just something quick like that, just so that way I can clearly see that you know what you're doing. It doesn't need to be long. You don't need to give me a whole paragraph, a sentence or two at most, um, and I'll know what you're talking about. All right. So that's a very common thing that you'll have to do. The other common thing that you'll have to do is a lot of distance formula. All right. And the distance formula ones can kind of be annoying. I'm not going to deny that. That's why you kind of want to make sure you have the correct points. So, given that this is a right triangle, triangle ABC, whose vertices are 2A, 0, 0, 2B, and 0, 0, let M be the midpoint of the hypotenuse AB. We are going to prove that AM is equal to BM, which is equal to CM. So our goal is to prove that all of those are equal, which would mean we need to figure out the length of all three of them. Now, in order for us to do that, we need to figure out the midpoint, the coordinates of the midpoint, right? So we will need to use our midpoint formula. So our midpoint of AB, which we're calling M, so 0 plus 2a over 2, 2b plus 0 over 2, well, that's just going to be a. Now, that's why you would call this 2a and 2b, because if you didn't do that, you would have ended up with a over 2 and b over 2. And since it's arbitrary what we're calling them, that's why you usually want to put a 2 in front. All right, so we have this coordinate now. This is AB, and this is 2A, 0, 0, 2B, and 0, 0, right? So I'm going to mark that down. This is AB. Now I need to find the distance between all of these things. So, I don't know, it doesn't matter. Let's start with AM. So the distance formula, right? So we have to do the distance between these 2 points. What's the change in x? So 2A minus A plus 0 minus b squared equals a squared plus b squared. Okay, I really can't do anything with this anymore. So let's just look at the next one and see what happens. BM, well, what's that? 0 minus a squared plus 2b minus b squared, which is a squared plus b squared. Again, we don't know what this number is. It's just some number. However, this is the square root of a squared plus b squared, and this is the square root of a squared plus b squared. These are the same. I don't know what they are, but they're the same. All right, and then finally, last one, 0 minus a squared plus 0 minus b squared. By the way, I'm just skipping over the part where I'm saying it's negative b squared, which is just b squared, because you get the point. It's a squared plus b squared, right? So I don't know what these are. They're some number, and they're the same number, okay? So because they are all equal, right, since AM, PM, CM are all the square root of a squared plus b squared, right? Since they're all that, AM plus BM equals CM. Oops, AM equals BM equals CM. All right, that's all. The tricky part about this is that you see this and go, I don't know what to do with this. You're right. You probably don't know what to do with that, but that's okay. You don't need to do anything with that. You're done. And I know you're going to look at this and go, I don't want this to be how I end this, but this is actually how you're ending this. So anyway, please let me know if you have any questions on these. These are two very typical types of things you'll do: distance, perpendicular. All right. So let me know if you have any questions, and have a great day.